Hey VC students, welcome to another video of hok'stutoring. Today we'll be going through a tutorial question or tutorial type video on your maths methods textbook. So we'll be going through chapter 1H question 6. This is the application subtopic of chapter 1 and it tests you on pretty much everything you've learned in chapter 1. So your basic functions, your hyperbola, as you can see from the equation already, and maybe the graph. And we're going to also be looking at implied domain and ranges, and then just sketching the graph in general. So this is going to test a bit of your problem solving skills, and without further ado, let's get into the video. Question 6, let's have a read. Let the function f be restricted by the domain 0 to 6 with the equation 6 divided by x plus 2. Well, immediately we know this is hyperbola with a vertical asymptote of -2 over here from the bottom, because if you sub in x equals -2, you'll get an undefined. So that means that's your asymptote already. And then the horizontal asymptote, if you remember from your year 11 studies or VC methods 1, 2, you'll know that the horizontal asymptote is 0. So quite evident over here. If you want to draw an invisible line, there's -2 and there's a 0. But anyway, the draft's been drawn for us, so that's good. Let's keep moving. Rectangle OBCD is formed so that the coordinates of C are A, FA. Well, we know this graph right here is the graph fx given to us. We know that this point C has an arbitrary value of A. We don't know what that is, but it's just been given to us. It's a variable. We'll leave it as that. And if, of course, if you sub in A into your fx, you get f of A. So that's your y value. So that's pretty cool. They've given that to us. And then we know that this is a rectangle, OBCD, and it's quite evident, you know. It's got its length, it's got its width or its height, whatever you want to call it. And OBCD, pretty much same height. ODBC, same length as well. So let's keep reading the question. A, find an expression for the area of rectangle function A. So this over here is our only rectangle, and we want to find the area, or at least an expression or some kind of equation to show this area. Okay, so that's part A of the question. We'll solve that very soon. Let's just keep reading a bit quickly. Part B, state the implied domain and range of A. So we just want to find the domain and range, you know, like what's my graph or what's my area restricted to. And then part C, state the maximum value of AX for x belonging to 0 to 6. So essentially just finding what's my maximum area for A or this rectangle given my graph over here. And then part D, sketch the graph of y equals AX. So essentially just once you find the expression or equation for A, you can then sketch that. So that's part D. All right. So now that all the question and the reading's over, let's get into answering the question. Part A. Find an expression for the area of the rectangle function A. Well, we know that an area of a rectangle is given by length times by width, or length times by height, whatever you want to call it. We know over here our rectangle, we've already labeled this, actually, this is the length and that's the width, right? So how do you find an expression, you know, preferably in terms of x or in terms of A, things that would be given. So how would you find the expression for that? Well, this is crucial. The point C, they've given to us that point C is AFA, right? So you can essentially say that, you know, the length of this rectangle could be, you know, from 0 to D. Another way of saying that is actually A, because the x value of A from here to here or from B to C is A, meaning O to D shares the same length as well. And likewise, from D to C, so the height of this is FA, because that's the y value, right? So you can say the height of this rectangle is FA. In other words, the area is simply just A multiplied by f of A. And if we were to express that in terms of, you know, an expression that's a little bit, you know, better than just A multiplied by FA, you can say A multiplied by, well, what is FA? We know that fx is 6 over x plus 2. So FA is just essentially replacing x with the A, and you get 6A plus 2. And then what you end up with is 6A divided by A plus 2. And there we go. You still end up with a hyperbola, although not as nice looking as the previous one, because now you have an A on the top. And of course, I mean, some of you might already be on top of this, but you can simplify this even further because, again, your power on your numerator is the same power as your denominator, and as we know, you can long divide this. So if I was to do a quick long division just on the side over here, and I might just mark that in green. So your denominator comes down over here, and your numerator is over here. You're trying to divide that. Well, how do you get rid of this a? Well, 6a, I should say. You multiply a plus 2 by 6, because if you multiply that, you get 6 multiplied by a, and then 6 multiplied by plus 2, you get plus 12, and you can put an invisible plus 0 over there. 6a minus 6a cancels out, so that's good. And then 0 minus positive 12 gives you negative 12, and that's your remainder, which we're going to use to write the new expression. So instead of writing, 6a divided by a plus 2, which is correct, but it's not the best form, because we know in a hyperbola, you want to see, your numerator has to have the degree of power lower than your denominator, right? So in this case, what we want to see is, well, you have your quotient, which is the 6. So again, the formula for a hyperbola is quotient plus your remainder divided by your divisor. And to put into maths format, or in this example here, it is 6 plus, or in this case, because we have a minus 12, we just put minus 12, that's your remainder, divided by your a plus 2, which is your divisor. There we go. So that's another way of writing this, and it looks a lot nicer. Why? Because you can immediately tell that the horizontal asymptote is 6. So that's your horizontal asymptote. Immediately you can tell that's, positive 6. And you can tell that the vertical asymptote, so vertical asymptote is going to be minus 2, which is going to be very useful in determining, your domain, your ranges, your graphs, all that sort of stuff. But there we go, guys. This is your expression for the area of this rectangle here. So might just highlight that. That is part A. There we go. So that's part A all sorted. Let's move on to part B. We need to find the implied domain and range of A. So essentially, what's my domain? What can, A be up to? And then the range would be, what can my area be up to? How big and how small can it be? Well, let's do the easy one first. Let's look at domain. So domain of my graph, or of this area, is A, and just look at the graph. You don't even have to look at, consider the equation. Just have a look. What can my value of A be? Well, obviously it can't be negative, so you can rule that out. So it has to start from 0 all the way to a value, right? Well, what can it be? Can it be infinity? Can it be 10? Can it be 100? Or what can it be? Well, I've been restricted here. See, my graph here has been restricted all the way up until 6 only. So that means my A can't go any higher than 6 because, well, it's already been restricted, right? So it means your A value can only go up to 6. And now you just need to put the brackets. Well, can I take an inclusive 6? Yes, I can. See there, if you have your A here, you just form like a slightly longer but shorter rectangle. So yes, you can. And if your A value at 0, so that means A is over here, what you form is just basically a stick. And it's a bit debatable, but I would say you can include that. It just means your area is 0. Okay, that's it. So that is your domain. Now, what about the range? This one's a little bit trickier, right? So what can my range go up to, It's not as immediately obvious. Like, what's the smallest value of A? Well, this one actually is, the small part of this is quite simple, 0. It can't be a negative area, and we already can see that if you have a stick as your rectangle, it can be from 0, or your area can be 0. But what about the big value, right? Like what's my biggest area for A? That's, you can't really tell from just looking at the graph or looking at, this diagram over here. So if you want to find that, you need to look at the equation over here, right? So let's have a think. My A value can only be from 0 to 6. If I sub in 0 over here, then I get 12 divided by 2. My denominator is just 2. So you get 6 minus 12 over 2, right? And then if I keep subbing in a higher value of A, you get 6 minus 12 divided by, well, if I sub in 1, I get 1 plus 2, which is a 3. And that's essentially So if I was to simplify this, you get 6 minus 6, you get 6 minus 4, and that's that. And then if I keep going on, right? So 6 minus, if I sub in my a, if I just keep increasing my a value. So let's try, 2. So that means if I sub in a equals 2, 2 plus 2 is 4. So I get this. So 6 minus 3. And you can see that as your a keeps getting higher, your area actually keeps increasing. So, see 0, 2, 3, and if you keep subbing in, you'll get a increase in area. So if you keep thinking about it, right, and it makes sense, your denominator, as your a gets bigger, your denominator gets bigger as well. But a bigger denominator means a smaller number as a whole, because 12 divided by, a bigger denominator gives you a smaller number, but then that smaller number, when subtracted from 6, gives you, well, the bigger area. And as you can see, this is the pattern. And if I try to sub in 6, right? So if I sub in a equals to 6, 6 plus 2 gives me 8, 12 divided by 8, and I get, well, let's simplify that. You can divide both numerator and denominator by 4. You get 3 over 2. And a bit of fractional deduction, make them the same denominator. So this 6 becomes a 12 over 2, same thing. And you get 12 minus 3, which is 9, and then everything's over 2. And we can see that this area right here is the biggest that you can get. And it's just a pattern kind of thing. So just a quick, I guess, if you want to find it out. Otherwise, we can sketch a graph, but that's later on. So we can immediately tell that the biggest area you can get is when you sub in a equals to 6. And in this case, we just replace this question mark with a 9 over 2. That is the biggest area that you can get. Essentially, when the box or the rectangle looks like this right here. Okay, guys? Not the best kind of sketch that I can get, but there we go. That's part B. That's the implied domain and range of A. So let's answer part C. This one is actually, if you already did part B, it's an easy answer. 1 mark, 3 mark. State the maximum value for AX for X belonging to 0 to 6. So essentially, we are just replacing A with the X. We know that my maximum value is 6. And we know the maximum area that you can get here is 9 over 2, right? Because that's the highest range you can get, seen from our working out over here. So that's pretty simple. We already answered this part with part B. And to put into words, this is your maximum area, okay? So max area that you can get given the domain 0 to 6. Now let's do part D, the last part. Sketch the graph of y equals to ax for x belonging to 0 to 6. So we already have our graph over here. So AA, we know, was 6 minus 12a plus 2. Essentially, you can just replace that a with an x. It's the same thing, 6 minus 12x plus 2. And just make sure your domain is between 0 to 6, okay? So let's try sketch this graph. Well, I'm gonna draw my axes just over here and right there. Okay, and let's do some asymptotes, because when you're sketching a hyperbola, and this is a good revision for you guys, if you don't remember how to sketch a hyperbola, we look at the domain, we look at the vertical and horizontal asymptote first. So we can tell this is the horizontal asymptote, and we can tell that this part right here is the vertical asymptote. So horizontal asymptote is just given by the value 6. A equals to 6 because my y value is now my a, and my x value is, well, that's still the x, so that's good. Horizontal asymptote of a equals to 6, and vertical asymptote of a equals to -2, because if you sub in a equals -2, you get an undefined. You get a 0 as a denominator, and that doesn't work. So x equals to -2. And we know that this graph has a reflection. Normally, a hyperbola graph just looks, something like this, top right and bottom left. But because there is a reflection over here, because there's a negative, then your graph gets flipped. So then now it becomes top left and bottom right, okay? So we know one section of the graph is probably going to look like this, and then the other one's going to look like that. but you need to be careful. You need to look at the domain. So my domain is from 0 to 6. That means I can't sketch anything on, before my x equals to 0 over here, okay? Anything on the left side, I can't sketch it. It has to go from 0, and then all the way to the right side. So we need to find out, right? So these are my endpoints. What are my y values or my a values when x equals to 0? So a, you sub in 0, get 6 minus 12 divided by 0 plus 2, and we get 6 minus 12 divided by 2, which is 6 minus 6, and that is 0. So conveniently, and we actually already knew this from the start, right? When my area, my rectangle, or at least when my a or my x was 0, I get a flat stick, which means no area at all. So that's why area is 0. And it's pretty evident over here too. When we sub in a equals or x equals to 0, you get an area of 0. So the graph starts from the origin, which is good. And then we just keep going on. We know my graph is going to keep increasing all the way, but we don't know it has to stop somewhere at 6, right? So might just sketch that a little bit better. Yep, it's going to stop somewhere at 6, okay? So at this point, when x equals to 6, that's an endpoint. We just need to find the y value, but we already know that, right? So when a equals to 6, as we saw over here, your y value should be 9 over 2. That's your area, your maximum area. And there we go, guys. That is how you sketch the graph. Ax equals to 6 minus 12 over x plus 2. Alright, there we go, guys. I hope this video makes sense. This is a good question for, I guess, your textbook, but then at the same time, it's also a good revision for your SAT. I hope this makes sense, guys. If you found this video useful, please leave a like and subscribe to the YouTube channel. That would really, really help this channel a lot. And if you have any questions, guys, please leave a comment down at the comment section below, and I'll try my best to get into it. Otherwise, I hope you have a great start to your school year if this is your, suppose if you're watching this in term 1. Otherwise, I'll see you in the next video. Thanks for watching.